how it's wired in for the wiring diagram once you start. Otherwise, chasing some of these wires is
so
tricky.
that'll be on the GitHub.
How does this
Should also be linked to
like interact with? Does it interact directly with the Pi?
I'm trying to move this now. Okay. Say it again.
So what is the like? So I'm
The
assuming
speaker. That's
the
or the C3 speaker microphone.
so that's for
which will be,
directionality.
if you go back to the software section,
And so when I'm talking to the well, it gets like a position.
scroll down.
Yeah, it knows where in space you are based on your thing. Well, it can, depending on what programming you run.
That's interesting. And what's okay? That's the yeah, the amplifier. Let's see. For the motors, what kind of control is that? Or is it like
it's
a
actually- so
separate
it's confusing
driver
with
board,
one
or?
There's an interesting variance. Have you guys ever worked with Dynamixels before?
Yes, I have.
I have not.
Well, there are different families. They use different protocols. The more industrial one use RS485, which can travel long distance. The cheaper version, like the AX family, use just the TTL serial 5 volt.
Okay.
And that's a very close range, at the close distance.
So what does each motor have inside of it?
It's a little computer. Little computer, there's an encoder.
Yep.
And so basically, it's just like your toy servo, except but it has a smarter computer. You can control it not just by precision, but also by its velocity, by torque. The more high-end version has give you a lot more control. You can download the entire velocity profile, so you can have very smooth motion. I don't know about this particular family of.
They're mostly the MX and AX. So, yeah,
Okay.
but so yeah, that's the key. Is that it has a potentiometer in there.
Right.
It has basically like a little Arduino, better than an Arduino inside the motor, which is very different from most servos that you have, because you know most servos are just kind of dumb. They have some of that stuff in there.
Right.
And then of course it has a motor in there.
Yeah, the normal toy servo, you can only give it precision, right?
Yeah.
But with those, you can control how you reach the precision, how fast, and how much
So we haven't built
power, so that some of them can be compliant. Let's say if you bump into the hand, you can stop because it reaches that compliance of the limit.
So that's how you were able to move the arm and then record the positional.
Yep. And the other interesting part about it is it can be daisy chained, right?
Right.
Where most servos, if you've ever worked with an Arduino project, they all have to go to a servo control board.
Each one has an
Yeah,
address.
so
Yes,
that's
individual
probably
address.
because of some of the development they did on the
Here's
Arduino,
the
the neck joint,
protocol
which
is
we
like,
use
kind of reminds me of like either
as part of
SPI or squared C devices where you can chain them and you can address them based on the addresses. It's kind of cool.
I mean, I'm not exactly sure what the technical protocols are on there, but I know that the inside, once you get into the software, the whole idea is that this can reachy is really
so when you move on to the rest
Python.
of the questions,
It's all about controlling your Python. Right? They chose to not go with ROS, although now you can install ROS,
so when you
but to control everything with Python. Even Luos has a sub-language called, controller. I'm not sure whether that's what they call it or what, but it's called PyLuos. And a lot of the commands are actually controlling that sub stuff through Python and everything. So it becomes, if you know Python, this is actually a pretty easy program, like, to control. I know nothing about Python, so I'm just a learning.
You know enough to get it working.
Just to be
That's all you
dangerous,
need to
that's
know.
all I know.
That's all you need to know.
Yep, but that's kind of the fun part of it. So you can see that it's all, these are the fans connected on it, and this will be the DXL board of the Luos.
Excuse me.
Right? And then you have, that's the speaker to the amplifier to the speaker.
So
audio cable.
is these board
Yep.
directed via USB?
They have USB communication to the Pi.
So taking a step back, how does the motors connect to the Pi? Is it through that board then?
Through that board.
USB?
Yes.
Interesting. Huh. I like how kind of air quotes plug and play that is.
Yeah, that's the plan, I think, with Luos. You know, you guys will get intimate with the Luos framework and understand the plus and minus, and you guys actually have. Once we look at this further, we'll have the opportunity to you know, possibly even change the architecture or to adapt it or to continue with it. So the more you guys learn about exactly what reachy is and what it can do and why, the more you guys will have an opportunity to contribute to the knowledge that is reachy, because you know, we're going to be developing things that no one's ever developed on reachy before.
Awesome.
They apparently have, you know, thousands of these robots out.
Really?
Yep.
But they don't even sell you those boards, so it's a proprietary the system.
You could technically make the boards. They released the KiCad models, you know, or the you know, the CAD models of the thing, and they released the firmware. But again, Pollen is not Luos. Luos is a different company, and Pollen reachy uses Luos, and so it's Luos, I'd say, is half or 3/4 open source.
There are
So
there's speed limits, angle limits, and torque limits.
Is there a force sensor? This was
it is not installed at the moment because
Yeah,
we were
but,
rushing.
you know, you're going to be presenting this
And
back
the
to the
force
group.
sensor is a very
so some
delicate
way to
thing. If you literally
describe
drop it,
what
you
those
can
limits
break
are.
it.
You can keep you
So
can
we
keep
didn't
the
want them to be
details as a
rushing
link, but
with
be
that.
able to talk through.
This will be one of the first things
You know,
that you
like
guys
what
will
those
get to actually
limitations are
do
and
for
how to
hardware
think about
team
them in
is
context
to be able
of the
to install
applications
the
we
force
might
hardware
develop.
or the force bar.
okay.
So you can play with gripping and grasping projects and all sorts of that too. Yep.
Okay. It's kind of interesting to think about how, for using an analogy of my arm, like this has each joint has its own computer.
Yep.
It is mildly amusing.
I mean, I guess they technically it's called the 6-off arm with grasping, which I guess is it's not quite a degree of freedom, but you know, there are 8 dynamics motors in this arm.
Is the fancy pivot thingy?
No. So the fancy pivot, this is just a solid. The head doesn't actually move right now. Right? The previous group was working on the Orbita, right? And it is all open source, but you know, it's a pretty deep engineering challenge. And of course, we didn't have the rules on PCBs for that. So you have, you do have, like, with the Orbita, we've done quite a bit of work, but it will take continued work.
It's a fork of the
to
original
develop.
reachy package.
So probably as we go through, we're going to talk about
It's
just
called
like
test
how much
right
work
arm.
is it to
That's
develop
the one
it?
that Dan was just running.
How much is it to,
So I just
you
dropped
know,
that in the
to
chat
integrate
here,
something
and
our
that's
own?
you specifically.
So
that gives you
I
the,
feel like
the
it'd be
notebook
almost a project in and of itself to design the PCB for the and design and test, build and create the Orbita on that side. So
Okay, I'm gonna drop off and see how the other group is doing. Okay.
they just have to decide on whether that's the thing that we want to do for hardware side. And with the putting together the other arm is a no-brainer. That's
Or cheating and just putting them
or
in order.
a little stepper or just a simple pan tilt mechanism. So those will be some things that we can do. But yeah, there is no Orbita in at the moment.
Okay.
We don't do this is stable. It can't move. Yep. You asked me what was inside the head. There's the 2 dynamics of motors that control on the little antennas.
Oh, that's how it gets the
Yep.
the wah.
Yep. And it actually, yep. It has they need a little adjustment, a little bit of play because they don't snap on quite as well.
Are you about to use it?
Sorry?
Are you about to use it?
Yes.
Ew. No, I just want to watch you use it.
Oh, sure, yeah.
What are you making?
Sorry, what is this?
Nothing.
Is this for yourself? Okay. Just cutting some acrylic for a printer downstairs. There's a protection from all the metal parts.
Cool.
Some very boring, basic 3mm acrylic that we got from down the road.
Yeah.
And this machine is old. The software is really crappy, but
I mean, it works.
it works well. Yeah, and it fits like a big sheet of this in here. I was gonna do it earlier, but there's like a whole class over here. I didn't want to disturb because of how loud it is.
What's your name?
I'm Sasha.
Hi, Sasha.
What's your name?
Olivia. Sorry.
Sorry, do you mind like keeping some distance, please?
Yeah, sorry.
Because I am a bit paranoid about this whole virus thing. Do you want me to explain what I'm doing? Or are you just learning, or?
Yeah, I'm just learning how to use it.
Wait, were you about to use it? Did I interrupt you?
No.
Okay, sure. Basically, whatever you add here, whatever you design, you basically create whatever file from CAD or through whatever drawing program, and you basically create a DXF file, which is a very basic file which just includes lines, and that's all you get. So you get these lines onto this program, and it tells the machine just to cut along those lines, and then it's like super basic and super simple, which is pretty cool.
Yeah.
Which there's other ones you can do like etching and etc. and do all these kind of things.
And you can use like Adobe Illustrator, right?
Exactly, yeah. So that printer over there is smaller, but it's newer. And that you literally plug in your computer directly, open up whatever drawing software.
And then
you
it
can-
just prints.
Exactly.
Yeah.
I forgot how to use that one because I didn't really use it immediately. So I used this ancient sort of software.
This one works well though. We watched it work yesterday,
Oh, wonderful.
and it printed out the all the pieces for the robot.
Oh, perfect. Nice.
Yeah.
Is the robot working yet?
Yeah. Yeah, we got the software working on it and everything. It was really great. We did the whole thing yesterday.
Wonderful. Are you learning a lot?
Yes. Like, I learned so much.
Problem is, this guy, I think the wood stinks up quite a bit sometimes. I'm not sure. Or certain things, you can smell it from across the building if somebody is cutting something particularly, I guess, smelly. Nope. There we go. So the whole point is like you want to make sure you're cutting where that shows that it actually is. There's a little indicator over here somewhere that I can't see. Oh, there's a laser off maybe.
It's not working.
Yeah, so there's usually a red dot, which is basically the laser, which shows you where you actually are. So see if I put my hand here,
Yeah.
there's a red dot.
Yep.
That's coming from the laser itself at the very back,
Yeah.
and it reflects it through the mirrors.
Yeah.
And it should reflect down here, but I don't see it, so I think there's some misalignment or something, which I'm looking at down. The laser pointer is not shining down through thing. Is it misaligned or is it? Yeah, most. Yeah, that's a little. Yeah, it's shining. If you put your hand at this part, you'll see there.
Likely. So let's just see if the pointer may not be working, but the laser may be aligned just right.
Okay.
I think you're fine. If you're just your pointer is off.
Oh, so this is like a different company.
It's a different laser source and a different alignment source, so yeah, I would say I wouldn't worry about it. Just be aware of these lines that you're going to be cutting right here.
Oh, yeah, no, I am zeroing it all.
Oh, you're doing the
Yeah, the mark.
What piece are you making right now?
Sorry?
What piece are you making?
A piece. We have a printer that has a lot of metal parts, which we have a high voltage field that causes anything we print to be attracted to the metal parts because it really acts as a barrier. So basically, it's nice and colorful to make it look pretty, but
Yeah.
mostly it's like a physical barrier to cover all the metal parts.
Okay.
And it's very like a perfunctory, super boring piece,
Yeah.
but it serves its purpose. So the whole point is that I'm going to focus the laser something right now.
It's your favorite piece. It's your favorite piece. I really didn't know. I like literally didn't know what that piece was for. I didn't
yeah.
get it.
I'm saying to, and then you gotta figure it out. It works well for the thickness.
Nice.
Check once again. Problem is like I always overcompensate for half or half on the CG because sometimes it doesn't cut that well, and then if you snap it, you get really sharp. If you like doesn't cut all the way through, you get a little bit of that.
Yeah.
And it snaps off, but it gets a really sharp, kind of like almost like a knife blade thing that you get from acrylic.
Yeah,
I've
we
cut
had that
myself-
problem yesterday.
Okay,
yeah.
so I've cut myself multiple times, so now I'm always like overly careful to make sure it cuts all the way through. It's gonna start. Really works. And now I just don't step away, otherwise Dan gets angry.
I know. Yeah.
And so because you saw, like, you can also do this kind of like more artsy stuff with the engraving and stuff.
Yeah, I saw it. The metal was like really cool.
Yeah, there's some really cool ones. Not this one that like have extra gases that allow you to actually cut through like steel or aluminum
Yeah.
or whatever other metals. But I don't think this one can. Well, you could probably try, but I'm not sure how successful it'd be.
Can we get you to